So I've been getting some questions about the simultaneous equations homework. Hopefully this example of, I think, 4C will help clarify some questions. And below is also 10A, which I'll go through as well. So with our whole substitution method, what we know is that we have a letter that equals a bunch of stuff. And what we want to do is substitute out the letter in our second equation. Now we notice that y doesn't actually fit perfectly into minus 2y. So what we're going to do is we are going to manipulate this side a little bit just to make it a lot easier for us to substitute. What I'm going to do is times everything by negative 1, turn that into minus y equals minus x plus 2. And then what I'm also going to do to equation 1 is double it. So I've got minus 2y minus 2x. So I've got minus 2y equals minus 2x plus 4. And by doing that, what we've noticed here is that this negative 2y is the same as this negative 2y here. Hence, we can substitute equation 1 into equation 2, and what used to be 3x minus 2y equals to 7 is now going to be 3x minus 2x plus 4. See how this whole thing replaced the minus 2y, and that still equals to 7. Now, for some of you, it might be really tempting to do the claw here. The reason why we don't actually need to do that is because if we just write this out, we're like, hang on, if we look at the brackets together, that's just, there's actually a plus that's separating these two here. So if we go 3x plus minus 2x, that's just 3 minus 2x. That's going to leave us with x. Then we go, hang on, like obviously we're not doing the claw again. That's just x plus 4 equals to 7. And then we have a really easy equation we can solve. So we're minusing 4 from both sides, getting the letter by itself to find out that x equals to 3. Okay? Now, what we'll do next is we are going to then sub x equals 3 into any of these equations that we've made. Now, I think subbing x equals 3 into this first one is actually going to be the easiest, because if I substitute x in 3 and I just have 3 minus 2, that equals to 1. So when x equals to 3, y equals to 1. We're going to just quickly check if that's true. 3 minus 2 equals 1. That's all good. And then 3 times 3, which is 9, minus 2, which is 9 minus 2, equals to 7. And so these are my 2 points of my simultaneous equations. Now, question 10 is a little different. Question 10 basically just asks, if we know that parallel lines will never, ever, ever meet, then there's not going to be an x and a y point for a set of parallel lines. And how we can work out if lines are parallel is that we just need to look at their gradient. If m1 equals m2, that means the lines are parallel. Does 3 equal to 3? And so if we try and draw these lines on a Cartesian plane, we're actually going to find out that y equals to 3x plus 2 looks like this line here. Y equals to 3x minus 1 looks like this line here. And they will be parallel and actually not have a meeting point, which means we can't actually solve the simultaneous equations with them. And if we try and we substitute 3x minus 1 equals to 3x plus 2, because we said the y's were equal, we'll be like, hang on, 3x minus 3x actually just cancels out, and it's actually physically impossible for negative 1 to equal to 2, which is why these lines are not going to meet ever.